Hello, everyone. I'm going to give people maybe 15 seconds to get settled. Seems like some people are getting settled. Excellent. So hi, I'm Fong-Jones, and I'm a developer advocate at Honeycomb, which is a company that provides observability to companies. And my illustrations are done by the wonderful Emily with curls. So those are not by me, but they are definitely great illustrations, I happen to think. So today what I want to tell you about is how we can make production simpler, how we can understand our production systems. And if my clicker would work, there we go. Okay, so we live in a world where we have more and more production systems, and they're more and more complicated. We have so many different microservices, we have so many different environments that we're scattered across. And unfortunately, these same techniques that used to work for us don't work anymore. Especially in situations where you're scattered maybe across a data center and a cloud provider. Or maybe you have hundreds of different microservices. Some of us can dream of getting to that point, right? That's not everyone. But at the end of the day, the problem is that we no longer have a clear definition of what up and down mean. Does up mean that all of my servers are up? If 100% of my servers are responding to ping, does that mean that my system is working correctly? What about measuring starting with user complaints? What if I wait for the calls to come into my customer support center and then I say, oh my goodness, my service is 100% down? I don't think that works very well either. So even if you have a great measure of that, how about juggling everything else that we're supposed to do as people who practice DevOps? How do we manage to find the time to do that when everything is constantly on fire? I think that we need to look at the problem starting from the beginning and figure out why are we here, what are we trying to do, and figure out what strategies will work for our environment today. One thing I know is true. Don't buy DevOps. With much love to our friends in the vendor hall, and including to myself, right? I do work for a vendor. I do have stickers. You can see me afterwards. Don't buy DevOps. Here's what happens if you try to buy DevOps. Well, let's put all of our developers on call. Let's go buy PagerDuty and put every developer on call. That'll solve our problem, right? And let's go and put in some wonderful continuous integration, continuous delivery systems, because shipping more stuff faster, right? Let's ship as much crap as quickly as we can, right? That's going to solve our problem. Or what about if we, what's a Kubernetes? Do I need one? I guess I want one, right? It's in the alphabet soup. I want to order it. That's clearly going to go great, isn't it? And let's get some infrastructure as code, too, right? Let's get some infrastructure as code so we can automate breaking our production as quickly as possible. So what happens when you do that? Well, your engineers get really, really unhappy because they're getting woken up every single night by things that they can't understand, that they can't fix, and the complexity is rising, and they feel like they have no control. And eventually, they shut off their pagers. And that sucks. And even when someone does decide to investigate, that vendor that you brought in to do these wonderful dashboards, well, now you have 100 different dashboards with 10 different graphs on each one. Which one should I look at? I don't know. Well, I guess I'm going to spend the first 20 minutes debugging anything, looking at this wall of dashboards to see which line wiggled at the same time as this other line. So that's not so great either. And then on top of that, people add all these other dashboards that they think are useful that solve their last incident. Well, their last incident is not your last incident. So the net result of that is that your incidents take forever to fix, your users are getting unhappy, and maybe you have one expert on your team. How many of you are that expert? Everyone bugs you for help. Yeah, I know the feeling, right? When you're that expert, then you can't actually get anything done, and you can't ever go on vacation. And even if you have the most beautiful continuous integration, continuous delivery in the world, if all you're doing is testing each individual box rather than how the system relates to itself, then you're going to wind up having the space between your connections, right? The space between your services break. And then stuff doesn't roll out and stay in production because you're constantly rolling it back all the time. So this is a state that we call being operationally overloaded, where you have no time to get projects done because you're getting paged all the time, you're getting interrupted all the time, you can't make any progress. And even when you do have time, there's no plan. You're lost in the woods, you have no map, and you don't know, how am I going to get myself out of this mess? So you and your teammates are going to feel like you're struggling to hold on, like you're just barely hanging on to the system and its complexity by your fingernails. So what did we do wrong? Well, OK, first of all, we bought the alphabet soup. But besides that, what I'd argue that we're missing is that we failed to start with thinking about who operates our systems and optimizing for their reality and optimizing for their happiness. Our tools are not magical. Tools can only help you automate something that you already know how to do. If your processes are not set up in order to facilitate effective debugging and troubleshooting, no tool is going to help you. We really need to invest in having excellent people, culture, and processes in order to effectively run today's production systems. So this is what I call production excellence. We have to make our systems feel that they're friendly to work with and that they're more reliable and more resilient. You can't get there by accident. You have to establish a long-term roadmap and plan and figure out, how am I going to get there? And that involves, yes, sometimes a Trello board, right? Thinking about what actually matters, what am I measuring, how am I going to get there? And you can't just do it with a set of people in this room. I'm sorry, right? Like, you have to reach out to people across a wide range of teams, including both people who operate systems, people who design and write systems. Obviously, some of us are both, right? As well as folks that you might not expect, like your business side, your sales teams, your product managers, your support teams. These are all important stakeholders that if you go off and charge ahead and do your own thing, you're not actually going to bring them along. So bring everyone along. And not just invite them to sit at the table, but actually encourage them to participate. Make sure that we have a safe, blameless culture where everyone's encouraged to ask questions. And in order to do this, I think that there are kind of 4 key things that I'm going to tell you about today of how we achieve production excellence. The first one is, we need to know, when are things too broken? Not, are things broken right now, oh my goodness, it's on fire, but instead, are things too broken? Are they trending up? Are they trending down? And when things are too broken, we need to be able to debug our systems with each other together when our systems are too broken. And finally, we need to close that feedback loop. We need to be able to eliminate unnecessary complexity. Every system, of course, has complexity. Some of it's essential. Some of it is related to the business function that we're trying to provide. But a lot of our outages come from places where we've introduced too much complexity or too much technical debt, and we need to kind of have a plan to reduce that. So how do we do this? Well, I'd say our systems are always failing. We need to embrace that. That is the way of DevOps. We need to think about the idea that our lawn's made out of grass. We don't care if every single leaf is green. It's OK if a few are brown, right? Like, that's OK. So we have to focus on, what does the system as a whole look like? And measure, what does too broken mean? So for this, we need the concept of a service level indicator. A service level indicator and its companion, the service level objective, give you common language to talk with your stakeholders, to talk about what is the level of reliability that we're targeting, and how are we measuring it? How are we achieving it? And the way that I like to think about a service level indicator is in terms of events in their context, and events that specifically impact users, right? What is the workflow that someone goes through if they're trying to add an item to their shopping cart and check out, right? Think about, is this event, is this user experience good or bad? And can it be determined not just by a human calling up your support center, but can you proactively detect whether or not an experience is likely to make a user upset? And if you don't know for sure what causes that and what's correlated, maybe ask your friendly neighborhood product manager, or maybe take on kind of the product manager hat yourself and interview some users, talk to them, figure out, do I abandon the page when it takes more than 500 milliseconds to load? So that kind of centers the idea of thresholds, right? Thinking about how do I divide these events into good and bad? One criterion that I might hypothesize, for instance, is maybe on my sample service that if a request was served with HTTP 200 and it took less than 300 milliseconds, that's a good event. But of course, I don't want to track every event coming in, right? You know, you have your health checks, you have your botnet attacks. You probably don't want to count those against the set of events that are user events. So once you have your set of eligible events and good events, then you can see what is your total availability and set a target on it and decide what level of reliability am I trying to achieve and over what window of time. For instance, I might say I'm trying to target having 99.9% of user events be good in the past 30 days, where each event means that it was good if it was served in less than 300 milliseconds without an error. And a good service level objective barely keeps users happy. If a user occasionally encounters an error, that's OK, as long as they can click reload and have it work fine. Now, of course, that may vary, right? You know, the difference between an e-commerce website and an airline is very different, right? You probably don't want your planes falling out of the sky. So we can kind of think about what's the appropriate level of reliability that allows us to move as fast as we need to while keeping our customers happy and safe. And then we can use that for things like alerting. So we can think about, when do I need to wake a human up? When is it important enough to wake up a human, and when can it wait for the next day? So to do that, we need to think about the concept of an error budget, to think about how much an availability am I allowed. So if I'm targeting 99.9%, that means that 0.1% of requests are allowed to fail over a 30-day window. So then I can look at how quickly am I burning through those allowed errors, right? It's like, how quickly am I burning through money in my bank account balance, right? Am I going to run out on Saturday? Am I going to run out 3 months from now? When does my next paycheck come in, right? And then you can take action. And only if you're going to run out of your budget in a matter of hours do you need to wake someone up. Otherwise, you can file a ticket and let someone deal with it during business hours. But the other really powerful thing about service level objectives is letting you make data-driven business decisions. For instance, is it safe for me to do this risky experiment, given that I know I can roll it back within 30 minutes and it'll only affect 1% of users? Well, if I've got plenty of error budget left, if the service has been stable, why not? That error budget is there for us to iterate and use for velocity. But if I'm running low, maybe I need to spend more time re-architecting the system to make it more reliable. So you don't have to get it perfect on the first try, because measuring is the first step to doing anything. If you don't measure, you don't know what you don't know. So measure what you can today, but think about, how am I telling whether or not this aligns with the user needs? Maybe users don't actually care that it's less than 300 milliseconds. Maybe they care that it's 500 milliseconds, or maybe they care about something else entirely. So be open to that feedback. So once you only alert on what matters, you're a good way towards achieving production excellence. However, that's only half the picture. And the reason is that it doesn't matter whether or not you get notified of an outage if it takes you forever to fix the outage. So our outages are never identical. They don't work in the same way every single time, or if they do, you're not actually fixing your outages, you're just letting them happen over and over, right? So you can't predict in advance what failure modes are going to happen. You can't predict in advance what questions you're going to need to ask in order to debug a system. So you have to be able to debug new problems in production, not just in your staging environment, in production. Otherwise, you're never going to be able to figure out, hey, the site's down and I can't figure out what's going on. And you have to be able to form and test new hypotheses, right? You have to have people feel like they can ask their systems any question that they want. If you don't empower your humans, if you take their autonomy and power away and say, this magical AI system is solving all of our problems, you're not actually empowering your humans. It turns out that the most powerful DevOps tool is not anything living in the cloud. It's between your few ears. So that means that we have to be able to explore data. We have to be able to ask these new questions and get answers. So our services have to be observable. And to define observability, in my own words, what observability means is that our systems can explain themselves to us and can answer questions that we have without us having to deploy new code. And that we can look at our events in their full context to understand how do they relate to each other. And how can we tell what distinguishes a bad event from a good event, right? To figure out what went wrong by figuring out what is the difference between these two categories of events. And really, the gold standard of observability is when your systems are automatically mitigating what's going on so that you don't have to interrogate your systems in real time, but instead, you have enough telemetry in order to understand what happened hours after the fact when you're debugging later once you've woken up after a solid night of sleep. So SLOs and observability go really well together because one is about detection and telling you when things are too broken, and the other one is, OK, things are too broken, how do I fix it? But that doesn't alone solve the production excellence problem. You also need to have collaboration between different teams. Heroism of being that one person who's the expert in the system just is not sustainable. You cannot do it day in and day out and rely upon it to create a resilient socio-technical system. We have to think about debugging as a collaborative activity that's done by more than one person on the same team and done between different teams. So many outages today happen because of intersections between different teams' services rather than being localized only in one service. We have to work with each other, and not just between engineering teams, but also thinking about working with support, working with data center ops, thinking about all of these job roles that we have to collaborate across who all benefit from working on production excellence together. Because at the end of the day, all of us are here doing our jobs because we care about our customers. And collaboration is fundamentally an interpersonal thing. Collaboration fundamentally relies upon having people have the trust to give each other feedback, having the trust to raise their hand and say, I don't think that looked right. Like, can we go back and look at that? If you don't wind up having people feel safe to work with each other, then your system's not going to wind up being very reliable in the long term. I know that Charity and I talk a lot about service ownership, but service ownership does not mean selfishness, right? Service ownership doesn't mean that this is my set of Legos and I'm not going to share it, right? What it means is you are accountable for that, but it doesn't necessarily mean that you're not willing to work with other people in service of achieving reliability for that service. So don't ship your org chart. And we really have to think about leaning on our team in order to achieve a high degree of resiliency. When you are trying to achieve sustainable operations, it means that you have to fairly allocate responsibilities across your team. And I say fairly and not equally. That's important. Think about people on your teams who might, for instance, observe Shabbat. Should you put them on call on Friday in the evenings? No, right? We have to be able to cover for each other. Think about the person on your team who's just had a kid. Think about the manager who has meetings during their day and therefore can't be on call during the day. If we all pitch in and work together and create a fair and equitable on-call schedule, we'll have a much better functioning team. If you cannot sleep, you cannot be creative. So make sure that people, if they've had a rough night of on-call, get enough sleep the next night. And also, make sure that you're documenting things as you go along. Like, leave yourself cookies, not traps, in the words of my friend Tanya Riley. You have to write down the right amount of detail. You don't want to write down things that are going to become out of date, right? But you have to give yourself enough idea of how do I start debugging the system? How do I understand what's going on? How do I mitigate right away? That's honestly the most important part of documentation is, hi, I'm a new SRE on your team, and my pager just went off. How do I mitigate and get things back to normal as quickly as possible? So don't runbook everything. It's just mainly, what are your mitigations? And we really have to fix that problem of being that hero on your team. Find that time to share your knowledge. Find that time to write down the questions that people are repeatedly asking you and the answers so that they don't have to ask you every single time. You have to think about the fact that one day you would like to go on vacation. You have to think about how do you empower your team to onboard new engineers. If you don't do that, then your new engineers are going to be hopelessly lost. And it's not just a matter of pushing information at people. You also have to make sure that you're hearing from them what their questions are and not yelling at them of, how could you possibly not know that? Right? Instead, think about, that's such a great question. I'm glad that you asked it. And it sounds like our documentation is not clear enough, right? That clearly shifts the tone of the team depending upon which of those answers people get when they ask questions. So reward that curiosity and also reward people who go above and beyond to do things for the team. Really reward that teamwork. In Honeycomb Slack, and actually on our community Slack, we have a channel called #love, where people say, hey, I'm really grateful to my colleague Dai for helping me with this UI bug, right? Or other things where you're like, yes, thank you. It makes people feel seen. It makes people feel appreciated. And of course, do blameless postmortems. So we have to learn from the past in order to make our future work better. And that requires thinking about, how do I make my future work less painful and learning from my previous mistakes? So I said earlier that outages don't exactly repeat, but outages definitely do rhyme. In particular, outages frequently share common characteristics that you can identify by looking at patterns of them over time, or even better, you can look at and proactively try to analyze your system to figure out what are the risks that you know about. Of course, there are always going to be risks that you don't know about. For instance, maybe I have a bridge, and it's crossing a river, and the deck is falling down. Cars are falling through the deck, and maybe it needs a seismic retrofit as well at some point, and maybe every 100 years there's a freak tsunami. But we don't know about that yet, right? Which things should I prioritize working on? I think it's important to think about how often does the risk happen and how bad is it? And by how often, I mean the time between incidences that you know about. For instance, it might be the case that I operate a continuous integration system, and everyone loves to check in their code on Friday afternoons, right? So my system gets overloaded every Friday afternoon, right? That's a pretty high frequency. It happens every week. But what's the impact, right? Maybe the impact is that our builds take a little bit longer to go out, but they still go out, right? So maybe it's not so bad. So think about how many people are impacted and how severely. Often, you have a lot more control about the impact than you do about the frequency. For instance, I can't necessarily control the fact that everyone wants to check in their code on Friday afternoons. But what I can control is making sure that instead of the system breaking for everyone, maybe we tell 30% of the users, sorry, you can't check that in right now, right? And that lets 60% of the stuff flow through, right? You can reduce the fraction of people affected, or you can reduce the length of time that they're affected for. And by multiplying these two numbers together, you kind of get the total amount of risk. And you can think about which of these risks are the most significant that you know about, right? There's always going to be risks that you don't know about. And then we can think about, how do we address these things? How do we address these risks that significantly impact our service level objective? If I know that I'm allowed to be down 0.1% of the time, and I have a failure mode that's going to take me down for 0.05% of the time, that sounds like that's a significant risk, right? That's half of my error budget. Maybe I'd better fix that. So having that kind of quantitative analysis, even ballpark, can help you make that business case and say, yes, we need to get that on the roadmap. We need to fix it. And actually, once you write down this list, it doesn't matter if it's not going to have an impact if you don't actually do it. So do make sure that you actually prioritize completing that work. And when you learn new things from outages, make sure that you're writing that down on your list of things that I might want to address, and you will have the ability to order them by priority, right? Not every postmortem action item is something that's worth fixing. Some of them are so low in the impact or so low in their impact on how often something happens that it may not be worth doing, and you might be better off working on other higher impact things. But I think that when people do these kinds of incident analyses, one thing that they fail to notice is systematic patterns. So let's talk about systematic patterns. If you do not have observability, that is a systematic risk. If you do not have the ability to understand what is going on in your system quickly and the ability to quickly mitigate, every outage is going to take at least 20 minutes longer. That adds up really, really quickly. And that really goes to the point of thinking about not just, as the sponsor who spoke before me said, how quickly can you get the data in order to understand what's going on in your system right now, but also, can you answer those questions that you have about your system and not just what you thought to instrument at the beginning, right? Can you quickly pick out the signal from the noise as a human being and not having a machine tell you what they think is important? Those are all important factors about making sure that you have appropriate reliability and observability. The other thing that I think is a secret team killer is the lack of collaboration. If you have people who get yelled at every time they say, hey, there's a customer outage, and you look and you say, my dashboards are green, there's no outage, right? Eventually, they'll stop raising their hand and saying, there's a customer outage. And then you're not going to hear about the big outage, right? It's really important to listen to your teammates and make sure that they feel welcome and included in the production excellence process. So I encourage you to, yes, do buy an appropriate amount of alphabet soup, right? If you know that you need something, then of course go buy it, right? Don't reinvent it yourself. But don't buy something just because you think it sounds cool. Buy it because it's actually solving a real business need. And make sure that you're not just buying the tools, that you're facilitating the overall culture and people and processes of your teams by encouraging them to practice good production excellence practices. So to sum up, I would say that production excellence is a great way of really bringing your teams closer together and involving everyone in production. And it requires you to measure when are things too broken, to be able to debug and work together to solve those problems, and then fix those problems over the long term so that they don't impact people as badly in the future. So that's all from me. Thank you very much for having me, and you can see me afterwards for stickers.